Today's session, session ID is CES 500165, and it's called Together We Can Do So Much, Civil 3D and Revit Collaboration. And I am your speaker. My name is Tom Richardson. I'm a CAD manager and associate at MWM Design Group. I'm also an Autodesk University speaker, one of the top 50 speakers last year. I'm a member of the Autodesk Expert Elite, also the Autodesk Group Network, for my work that I do with the Autodesk CAD Users Group. And something you might not know about me is that I'm a disc golf enthusiast, and the RHBH is right hand backhand. So that's a little bit about me. And today's class will cover setting up a shared coordinate system in Revit using the shared reference point tools in Civil 3D and Revit. We will also cover using that shared coordinate system to link Civil 3D drawings and Revit models. We will also be publishing a Civil 3D surface to BIM 360 and then linking that published Civil 3D surface on BIM 360 into Revit as topography. A few things that this class will not cover is download and installation of the shared reference point add-ins, creating base files, surfaces, data shortcuts, references in Civil 3D, exporting Civil 3D drawings to AutoCAD format, creating models, views, or view templates in Revit, and alternate workflows to create shared reference coordinate systems in Revit. For the class prerequisites, you will want to download and install the shared reference point for Autodesk Civil 3D. You need to download and install the shared reference point for Autodesk Revit. You'll also need a Revit model. You'll need some Civil 3D project drawings. And typically the Revit model starts out based on project internal coordinate systems, and the Civil 3D projects are based on survey coordinate system. And finally, to do the publishing and linking Civil 3D surfaces, you will need a BIM 360 design license and permissions on a BIM 360 design project. So learning objective number 1, setting up a shared coordinate system in Revit. So part 1 of this part of the workflow is we need to create a collaboration view. We're going to label our 2 points that we're going to use for coordination between the Revit and Civil 3D models. And those 2 points are called the origin and the up. So the origin is the rotation point. The up is kind of a quasi-north within the project model itself, or the Revit model. And once you do that, you're going to export that view to a DWG format. All that's going to be done in Revit. And then in Civil 3D, you're going to align that Revit exported drawing with your Civil 3D drawings. Now, this part of the process is pretty close, except for the labeling, the origin and the up, is a typical workflow. And that's why we're not going to cover it as part of this class demo. Now, part 2A is the part that we're going to do in Civil 3D. And this is where we're going to actually create the shared reference point XML file. And the way we do that is we launch the Autodesk Shared Reference Point tool, and then we select the origin point. Remember, this is the one that is labeled in the Revit exported DWG file. And then we're going to select the up or the Y point. And then we're going to be prompted to select the drawing units. And then we're going to select a location to store that XML file. Now, I noted on here that you want to make sure your OSNAP Z is set to 1 before launching the Autodesk Shared Reference Point tool. And this will force all selected coordinates to use the same Z value. And in fact, by default, it's probably going to be elevation 0. So what I call part 2B, if the Revit model that you're working with has a finished floor level or Z value elevation of 0, when you try to bring your surface in later on, it's going to be at real coordinates. So the vertical may not match. And if it doesn't match, there's a little cheap method that you can use in this origin. You can edit the XML file and change the 0 value to the finished floor elevation value that you want. So that's just one way to make sure that the elevations or the Z values match up from the shared coordinate system with the Revit model. So part 3, we're going to go back into Revit, and we're going to import the shared coordinates, use the import shared coordinates tool to import that XML file that we created within Civil 3D. And after you create it, if you want to immediately use it, you need to make sure and make it current, because just importing and creating the shared reference coordinate does not actually make it current. So that's an important step. And let's go ahead and see a demo of that process. So we started out with a Revit model. We exported that to CAD, and we overlaid that. I'll show you this drawing here. This is where I overlaid the architectural file, and you'll see it has a boundary. So I use the boundary as the coordination point initially. So now I'm going to create the XML file with this origin point and this up Y point. So this is going to be in the tool space, toolbox, and I expanded subscription extension manager, and then the Autodesk shared reference point tool. And here's the actual command. So I'm going to right click and execute. And that's going to run the command. And at the command line, it says select origin point. I'm going to do a shift right click and choose a parent intersection. And that's because I want to make sure and get the intersection of these two grid lines. Then I'm going to pick, you'll see in the command line, it wants the y-axis or the quasi-north. Again, I'm going to shift right click and a parent intersection. Pick this grid line and this grid line. So remember, the next step is going to be to select the units of the drawing, and you'll see that we have an option of feet. There is not feet and US survey feet. So feet is the only option that we have here of those two. Click OK. And then I'm going to pick where I want to store this file. In this case, I'm going to go to my local project. The project you're seeing here is stored locally. And this is the site. So I'll go ahead and take class off. You see I have a backup of the file made just in case. So I use the project number, and this is the site coordinates. So I'm going to click Save. And because I know I need an elevation of 757, I'm going to go ahead and find that project. So here's the project XML file that I created. And I'm going to go ahead and just copy it, paste it right here. Now I can edit the original. I just usually do it in a copy so that I know for sure that I have adjusted the elevation in some way in case I need to go back and make another edit. So I'm going to right click and edit. I'm going to change this to 757. And there are other ways to make this elevation match the Revit model. This is just the way that I'm showing you today. So I saved the file, closed it, and now we're ready to go back into Revit. So I'm back in Revit, and for me, I like to set up a view that has only the grid lines shown, because those were the 2 points that I used for my coordination. I'm going to go to the add-ins ribbon, and I have the import shared coordinates from XML file. I'm going to click on that, and I'm going to pick the first origin point intersection. And you'll see down here at the bottom, it tells you what it's looking for. Now I'm going to go to the Y or the up. I'm going to click that point, and now it's going to ask me for which XML file has the coordinate values for those 2 points. So in this case, I'm going to go ahead and use this one that I modified that has elevation in it. I'm going to click open. Yes, I do want to create it. and okay that it successfully is created. In terms of creating the shared coordinate system, that part of the process is complete. The one thing that is often missed is actually setting that coordinate system current. So we'll cover that in the next learning objective. So learning objective 2, we're going to use the shared coordinate system. And the way we're going to use the shared coordinate system is we're going to start in Revit, and we're going to make the shared coordinate system current. And then we're going to create an export setup using those shared coordinates. And then we're going to export the model to DWG using the shared coordinates. When you're creating the export settings, it's very simple. And we'll walk through this, but you can make a copy of the current one, and you're going to go to this Units and Coordinates tab, and you're just going to change the 1 DWG unit and set it to foot, and then you're going to change the coordinate base and set it to shared coordinates. It's a very simple process. And the next part of using a shared coordinate system is to go into Civil 3D and overlay that exported DWG file. Now, if we did the process correctly, we should be able to insert that Revit DWG export file, and it should drop into Civil 3D exactly where it needs to be. Once we do that in Civil 3D, we're going to update the Civil 3D base files, maybe make modifications to the building location, etc. And then we're going to export those Civil 3D base drawings to AutoCAD. And then part 3, we're going to go back into Revit, and we're going to make sure the shared coordinate system is current. And then we're going to link those exported files from Civil 3D into our Revit model. But note that I say that I recommend you link your copy of the Civil 3D exported file. Don't actually link the Civil 3D project files, because at the end of this process, when you save your drawing, it's going to ask you if you want to save those coordinates back to the linked CAD file. And if you do that, you're going to actually change the coordinate system of that drawing to match the internal coordinate system. It'll still stay in the same location within Revit unless you detach it and reattach it. But you don't want to do that to the Civil 3D team's drawings. When you bring in the CAD drawings using the shared coordinate system, it's important to check your settings, because your positioning is going to need to be auto by shared coordinates. Your place at is going to be whatever elevation or level that you're trying to target. I typically turn the orient to view off. The import units, you want to set that to feet, because that's the coordinates units that are being used in the drawing. And probably the second most important part after setting positioning to shared by coordinates is to uncheck the correct lines that are slightly off axis, because you don't want Revit trying to make something square that is actually not supposed to be square. All right, let's take a look at that. So we're going to start in Revit, and we're going to export that file. And we're not actually going to cover this in this class, because it's something that we already do. But if we take the site export file, export CAD formats, DWG, that's the process there. We already did that earlier, and we brought that into CAD. So we're not going to have to do that again. But to export this same drawing using the shared coordinate systems, we're going to go to Manage, Location, Site, and right here is the coordinate system that we created, or that's the one that we imported through the shared reference point tool. So I'm going to select it and make it current. And it'll take just a moment. and then I'm going to click OK. So now we have the shared coordinate system current. And if you want to confirm that, you can look at the orientation of a site view and change it from project north to true north. And you'll see that it does match the civil drawing now. I go ahead and set it back to project north. That's what I'm using for this view. And now I'm going to do the export. So same process from earlier that the architects typically do: file, export, CAD formats, TWG. Now the only difference is the one that I talked about here, is we want the shared foot export setup. Now what I did is I just took even if you just take the default one and you make a copy, and we'll call this one export shared underscore foot. We'll call this underscore class, since we're doing this one in the class. So once you have that selected, you're going to go to that units and coordinate tab, set it to foot, set it to shared coordinates, and click OK. Now you'll see that it says, shared foot. This is the class version. And I'm going to click next. And I'm going to select the location for the export. So I'm going to export it to a shared folder, the Arch shared folder, today's date. And this is the one that I exported earlier today. So this would be Arch site shared coordinates. That'll be our default name. Click OK, and that file is going to export. Typically, what I would do next is, as the civil person on the team, is I would go find that file that I exported and copy it into my civil drawing. And we have like a consumed folder, Arch, today's date. So here's the class one that I created earlier. And I'm going to go into Civil 3D. So this is my proposed site drawing. And this is the one that I want to send to the architect. And I want to make sure that I get the drawing back from them correctly, because if I do, then I know they have the shared coordinate system set up correctly. So I'm going to attach a drawing. And I'm going to attach the shared coordinates class file that I have, and click open and OK. And if it works correctly, like it does, then you'll see that it drops in exactly where it's supposed to. And just to show you, my insertion point is 0, 0, 0 and scale of 1. So with just a few clicks on the architecture side, you can have this project exported to units, foot, and using a shared coordinate system. All right. And at this point, as the civil team, we would go in and make modifications to this file, and then we want to export that file back to Revit for the architects to use. So in this case, I've already exported. So I did a C export civil 3D drawing. And from within here, I have all my settings the way that I want them. I exported it to a certain location. So now we're going to go back to Revit. So this is the same model. And now I want to bring in the proposed site drawing. And to do that, I'm going to go to the Manage Lab, to the Manage ribbon. You can also do this through the Insert ribbon. We'll go to Insert, and we have Import CAD. So I can import CAD. And I'm going to locate the files that I'm importing. Now, in this case, I have shared civil, and I have a couple of base files from today. So these are my 2 base files that I want to import. Now on BIM 360, we have permission set up that the architects cannot modify anything within the civil folder. If you do have permissions, it's very important to make a copy of those files. So that's what I'm going to do here. And I'm going to go into our architecture folder, consumed, civil, and I'm going to paste that folder. So this is going to be my latest files that were exported, my P site and my X site. I'm going to bring these in one at a time. I'm going to bring in the X site first because it has the boundary, and I can make sure that the boundary comes in the correct location. So again, number one important thing is make sure it's on the shared coordinate system. And you'll see that it actually doesn't have a shared coordinate system. So we need to make sure that the coordinate system is set correctly. Let me go back to manage, go to location, go to site, and it is set current. It is current. Go and click OK. This time I'm going to go to manage links, CAD formats, click add. Going to locate those files again. Now it says auto by shared coordinates. Yeah, it may have been because we went through the insert tab instead of the manage links location. So by going through manage links and then CAD formats and we clicked add, now you can see that our positioning shows us by shared coordinates. I'm going to uncheck orient to view, make sure we're set to feet, and make sure that that correct lines is turned off. Now I'm going to click open, and I'm going to click OK. I'm going to zoom in since I did preserve colors. Did that so you can easily see that the green line is the property line, and the black line, which I have highlighted right now, is the property line within the Revit project. So it did come in the correct location. So if we go back to manage links, CAD formats, click add. I'm going to bring in the proposed site, shared coordinates, uncheck orient to view, feet, uncheck correct lines, click open, and click OK. So now the architect can see the civil design that we have created. And you can see we've slightly modified maybe the width and location of the parking. But that is the process for sharing files back and forth using a shared coordinate system. You will begin now with the learning objective 3, which will be publish Civil 3D surfaces to BIM 360. Now, this process we will be doing in Civil 3D, and it's basically the collaborate ribbon, and we're going to do publish surfaces. So pretty simple process. But before we do that, we do have to do a little background stuff to make sure that it sends the information that it needs without a whole lot of extra data. And the way I do that is I create a surface export source drawing, which basically is a blank drawing where I create a promoted data reference in the drawing. And then from there, I'm going to need a location on a BIM 360 project where I can share the surface. So that's the next step, is make sure that I have that shared project folder. And the third part of the process is use the publish surfaces tool for each of the export surface source drawings. So when you see the demo on this, I think it'll make a little bit more sense. So I wanted to show you this process in real time, and just to let you know, I'm on hotspot data right now. So I have like a 25 maybe on my upload, or 2 on my upload and 25 on my download. So it's pretty slow speed right now, plus the Zoom recording going on. So the latency that you see is going to be partially from that. So what I have here is I have the proposed surface, And all I did to create this was I created a new drawing and I went to my data shortcuts. So I created the new drawing, saved it, went to my data shortcuts, surfaces, and on my FG surface, which this is the FG source export drawing, I did a right click and then I did promote. And what that does is it creates a data reference of that Civil 3D object in your current drawing, and then it promotes it. And I will save this drawing, and when I need to make an update, I will demote the surface with basically manage data shortcuts, surface, pick the surface it's supposed to be. I'm going to link it and then OK. And then I would promote the surface. So I can pick, right click and do promote, which it's not available right now because it's not a data reference. So it's real simple to update this drawing once you create it. What I'm going to do is I'm going to go ahead and save the drawing first. And the save is going to be going through BIM 360. So I'm going to launch my Autodesk desktop connector, and you'll be able to see that, okay, the save is going through now. And I like to watch it go through that process just to make sure that everything looks good. Looks good there. And then I'm going to go to the project folder. It's actually back here. Surfaces, and here's my surface. So you can see it's locked because I have it open, but it did save successfully. All right, I'm going to minimize that. Now I'm ready to publish. So I'm going to go to the Collaborate ribbon, Publish Surfaces. I'm going to run that tool, and this is the only surface in this drawing. I'm going to click the three dots down here. And I'm going to do that to select the file name. So there's a location I want. That's the shared location. And I have my file name. And I've already set this one to FG. And by default, the software is going to try to add .shared.dwg to the file name. And you cannot remove that .shared. It has to have that in order for this process to work. So I'm going to go and click Save. And that's where the file name is going to be. I'm going to click OK. And again, I'm going to go back to my desktop connector so you can see this in real time. It's going to process locally. It's going to save it. Then it's going to push it into the desktop connector. And it's already gone through the desktop connector. So that was pretty fast. And if I go back to where I saved that file, it's going to be under Surfaces. And it should appear here. And it may have been a file locking that went through there. But it should save in this location. And if it didn't, we'll go ahead and proceed with the EG class or the FG class shared. It'll be the same surface. But that's it for this demo. That's how you publish a surface. So it just has the .shared.dwg. Now, one thing I will say about creating that surface that's very, very important. When it publishes this surface, it's going to basically create a style that has the triangles turned on. So you don't have to do that. The software is going to do it in the background. But what you have to be aware of is whatever layer that tin is going to end up on, it has to be thawed in your drawing. So if you look at my layer manager, you'll see that I have turned all the layers on. The other thing I did in this export drawing is I set my units to unitless, and I made sure there was not a coordinate system assigned to this drawing. So I'm going to set that back. So that's what it was when I exported that file. And we're basically done with this part of the demo. That's how you publish the surface. So learning objective 4 is going to be linking a published surface, a published Civil 3D surface into Revit. So again, we're going to go into the manage links, and instead of going into CAD formats, we're going to go into topography. And then we're going to click add. So before you start, you want to make sure the shared coordinate system is set current. And then you're going to select a view that displays the topography, and then you're going to link the topography DWG file. And again, it's the one that has the .shared.dwg in the file name. Pretty simple process. Let's do a demo on that. So this is my site drawing, and I'm going to type VG. I'm going to scroll down and make sure that my topography is turned on. You'll see it is checked. And I went ahead and turned on the triangle edges just so you can see what that surface really is around that whole area, and that it's located correctly in relation to the building. So we're going to go to the Manage ribbon, go to Manage Links, Topography, and Add. And again, I'm on a hotspot connection, so the read process for reading these files within BIM 360 is going to be a little bit slower than what you're probably going to see with a better internet connection. So this is my project, and I'm in the folder that contains the surfaces, and I'm going to pick the FG class, and I'm going to click link. And it's going to give me a warning. What it's trying to do is it's trying to see if the coordinate system matches the internal coordinates on this project, and it doesn't. So it's going to say they don't share the same coordinate system. So we're going to use the world coordinates and align it with the shared project coordinates. So I'm going to pick close and click OK. And you'll see that the finished ground surface exactly matches the outside edge of my building. So the surface was imported correctly. And again, you may have to work with the elevation on that XML file to make sure that it comes in the correct elevation, or make sure that the Revit model is moved to the correct location in relation to the site. And that would be done through Relocate Project. So that's the process. That's the demo of those 4 learning objectives. So additional resources, you can reach me on Autodesk or Twitter at the same handle. And also encourage you to take a look at the Austin CAD users group. We do have a blog, and we are most active on the Discord channel. We also have a LinkedIn group where we do post some meetups. We also have a meetup group. I will add that link to the PowerPoint presentation that I upload. And for additional information on Civil 3D and Revit coordination, I highly recommend that you read the Augie World article by James Lord, and I've provided a link here where you can access that. It is free to view and worth your time if you are working with Civil 3D and Revit coordination, especially with surfaces. And that is my presentation for today. I hope you enjoyed it, and I look forward to any questions that you have that we'll be able to answer.